So this time we want to graph the function 2x cubed minus 12x squared using calculus. So our first step is to find where it turns and then look at the gradients at other places. So we want to derive, so we get our derivative there, 6x squared minus 24x. Set our function equal to 0, our derivative function equals 0, because that'll give us our turning point, our stationary points. Might not be just turning. So we get 6x, x minus 4 as in our bracket. So 6x will give us x is equal to 0. When x is equal to 0, y is equal to 0. That's pretty easy. This bracket will give us x is equal to 4, and that will give us then the point minus 64. So using calculus, we start to look at our values of 0 and 4. We know we've got a gradient of 0 in both of those. But what happens before 0? When x is equal to minus 1, we get a positive gradient. We sub minus 1 into our gradient function, and it curves rising. Between 0 and 4, well, at 1, we sub that in, we get a negative gradient, so our curve falls. So our curve rises, stops, and falls. So we get a maximum turning point there. And after 4, we get the value of gradient is 5. So, sorry, the gradient's positive at 5. So we've picked a value after 4, which gives 5. We get a gradient that's positive. So then our gradient must stop and turn and go up. So we've got our curve looking like that. So we get a maximum turning point at 0, 0. And 4 minus 64 gives us a minimum turning point because that's where it's stationary as well. So that's what our curve will look like. We said it rises, then stops, falls, stops, and then rises again. And we've got our stationary points. Because it's a cubic, we're not really worried about where it cuts through the axis as such. You can do it. We know it goes through the origin. You could solve that. That one wouldn't be too bad. But unless we're specifically asked, we don't really care. We're more worried about the calculus now at this stage. So this one here, we've got the function x cubed minus 12x squared plus 36x plus 10 leads us through the steps we need to show to end up sketching our function here. So first one, find the derivative, where we derive that function. So there's our derivative. We find the coordinates of 2 stationary points. So we're told there's 2, so we should get a quadratic. We do. Solve the quadratic. So we factorize and get x minus 2, x minus 6. So we get our values of 6 and 2. And then we get our y values there for 6, 10 and 2, 42. We will then determine the nature of the stationary points. Well, are they maximum, are they minimum turning points, or are they horizontal points of inflection? So we test 0, 4, and 6 because that's 0 and 4 before and after 2, and 4 and 7 are before and after 6. So we test them in the first derivative. So any of these 3, we can sub these values back into. We see when we sub in 0, we get a positive, so our curve's rising. Then it's stationary. Then it's falling. So subbing in 4, we get a negative gradient, so our curve falls. When x is equal to 6, we get a 0 gradient, so it's stationary there. And then when it's 7, we sub it in, and we find that we get a positive value, and we get a curve that's rising. So we've got our shape of our curve. We've got our 2 stationary points. So we should be able to graph that values there. Oh, sorry. Well, there's our part D, point of inflection. So we haven't really done much on point of inflection. That will come soon. But that's about looking at the second derivative. So we're not too worried about that at this point. So we'll look at those in future videos. But that's what we need to do. Get our second derivative, set it equal to 0, find our y value, and look for a change in concavity. More about that later. But there's what our graph starts to look like. So we're looking between minus 1 and 9. So at minus 1, we've got to get our value at minus 1. And we should get our value of 9, although our graph starts to run out. So we should only graph it between those points for that domain. So just be wary that when you've got a domain like that, you set that up. You've got your turning points though, and we are able to get our end values. In question 7 here, we've got to find the coordinates of the stationary points and determine their nature. So we know what we need to do. We need to get our derivative get our derivative there. We also want to set that equal to 0. Find our value of x. So that one will give us x is equal to 0. That will give us x is equal to 2. we sub it back into the equation there to get our y values. And then test the derivative on either side. So there's our stationary points. We test our points either side of those curves. So we get a positive, 0, negative, 0, positive. So that's the shape of our curve. So we know what it should look like. So we've got a maximum and a minimum turning point. When we graph it, we're able to graph it there. Now again, notice there that we've got a given domain. So -1 and 4. So we do our value, we set our values up, and we got our turning point. So we graph those, but we also look at, well, what's the end point? So when it's 4, y would be 16. So that's the point 16 there, and that would be the point -1, 4. So in that domain, what's the maximum value? Well, we're not looking at that. That's not its largest value in that domain. It's going to be 16, because that's where, when x is equal to 4, y is equal to 16. So that's what we're talking about when we're looking for the maximum value in a given domain. So we've got to check those endpoints, because that's where we should be stopping our graph anyway, because that's what we're told to do the graph between those 2 points. So we need to know those endpoints. So do that whenever you have to graph them in a given domain.